Hello and welcome to the Video Game Palooza Tech Channel. In this video, we're actually going to share with you a sample of one of our online training courses from our Hope Training Academy, which basically trains IT and cybersecurity, coding, and game development professionals in industry standard, recognized credentials. And so we have both on-site training, where you're going to be coming to one of our locations, currently all in the state of Indiana. And then also we have developed over the years a robust online training because actually it was developed during COVID, where obviously nobody could come into our schools. So we developed a online training course. We gave our students Chromebooks. And then what I'm going to show here in this video is a very quick, few minute excerpt on one of our networking courses, because we do have digital literacy, we have, A+, IT fundamentals, Network Plus, Security Plus. And like I said, depending on our student situation, we can go online and in the classroom. So if you sit back and enjoy a few minutes of education from this clip, we just wanted to give you some example of, and really some good information. It's just not just a sample, it's a few sections out of one of our courses of how the online works. But obviously we also, in our courses, we mix live instruction with video instructors along with the recorded videos, so that as our students may have questions and they needed a coach or somebody to help answer, whether it's the teacher or the coach, we also have those abilities as well. So our students can connect to those teachers, get those questions answered. All right, so sit back and enjoy some of the sample of this online training from Hope Training Academy Online. Take care. Hello and welcome back to day 2 of week 5. This is Rick Barretto from Hope Training Academy with our CompTIA A+ certification course online. So welcome back. If you remember, the first day of this week, we covered the basics of networking. So we covered some basic ideas and concepts such as bridges and switches, and if you remember, routers that are some of the basic things, network interface cards that compromise general concepts of networking. And we brought in some guest lecturers via video to help us just do a big broad brush picture. Today in week 5, we're going to be covering a couple more topics, and mostly what you see on your screen. It's basically media, network media, and network devices. And so we're going to go into more depth here, and you're going to see, since we've only got 2 topics, we're going to be going quite deep. So I'm going to try to stay on time, on track, to make sure that we're following along. And obviously networking is pretty deep, so you want to stop and pause, ask your instructors, ask myself if you have questions, because this is starting to get into really a lot of the meat of the information of this A+ course. So as you see right now, we're going to go on 6.02 in your test out and 6.03. So 6.02 is called networking hardware. So we'll bring up the slide and we're going to go into this. So DNS is, think of it as a phone book. It's the DNS where it says, in this case, you see test out is the name of the URL for the website. When you type in testout.com, the DNS knows where the IP address is. So this address, 216.58.217.46, is the DNS server. So when users type in just a word or hopetrainingacademy.org, it looks it up through DNS. It says, that's the IP address or the address, and then it sends it to the location. That's why you'll always find, if you've got a problem on your local PC and you can't resolve, meaning you type in Google or Yahoo or Hope Training Academy and it's not going anywhere, it says DNS error, DNS resolution. That means your PC is having a trouble communicating to the DNS server because it doesn't know where the IP address. You're just saying, okay, get me to eBay, and there's no DNS server, or the DNS server's down or confused, and it says, I don't know how to get you there. And that's the importance of DNS, very important server. Something else called DHCP server, Dynamic Host Configuration Protocol server. That's basically a service that you can turn on a server that instead of creating an individual IP address for each workstation manually, this DHCP server automatically deals out, like cards, right? Deals out and automatically assigns IP addresses. So if you think about if you're a small, medium, or large company, if you're the IT manager and you've got 1,000 users, we'll think about trying to keep track of and setting up manually each IP address on each printer, print server, file server, or workstation. It would be crazy trying to keep track of those. So DHCP, if you turn that on, basically it'll, as soon as you turn on a workstation, it'll hit the DHCP server. It'll say, aha, a new workstation. Here's your IP address, and it keeps managing it. It also has something called a lease, and a lease means that you only have so much time to have that DHCP address, and it'll renew or refresh to a different one, or the same, depending on how you set it up. Another type of network device is voice over IP, and this is your voice over a phone, like in the old days, the Ma Bell, the telephone, going over IP. So it's called voice over IP, and it uses the internet IP protocols to transmit your voice. So the cool thing is you can have a phone, an old-fashioned phone that's plugged into your network, and then you can talk, and then those analog voice signals coming out of your mouth sound is then encoded into digital zeros and ones, and it sends it out over the internet. So another kind of server called voice over IP. NAS is another type, network attached storage. So this is a storage device. Think of a hard drive, and we've talked about hard drives in the past. You remember there's different connections. This hard drive, which could be more like a server, has a Ethernet port, and that's why they call it network attached storage. So say if you have a 1 or 2 or 10 terabyte hard drive, I can put it on the network, plug in the network adapter, and now it becomes network attached storage that it'll be addressable and accessible for anybody that has permissions to do so on the network. As we move over to switches, can be unmanaged or managed. The unmanaged ones are not as expensive. The managed ones, as you might imagine, are more expensive because you can do a lot more of those, a lot more things, a lot more features. And these switches, when you first get those, if you think about it, it doesn't know anything about your network, and you have to get it onto your network. And this is something we'll actually do in our labs here at Hope Training Academy, is our students get to set up a switch. And as you might think, that it doesn't know anything, and it doesn't have a terminal, it doesn't have a screen, it just is a box. So there's no way to get into it. So what you have to do is you have to put these things called console cables or rollover cables. They look like this. They plug right into the switch, and then they plug into your PC. In this case, it's an older one, like a serial port. You would literally plug it in a serial port. Now via a telnet or a terminal program, you can go in and manually configure your switch. Same with the rollover cable. This looks more like a Ethernet port. It plugs right in, and now you hook this up to your PC so you can set it up and attach it to your network. Here's an example of what a console port will look like. Once again, you just plug it in there, and then you plug it into your PC. Now you can set it up. So as we switch over to patch panels and structuring cables, we had talked about different things like gigabit Ethernet. These are more talking about limitations that you can put no more than 100 meters of cable between the switch and the computer. There's solid cabling. There's patch cord cabling. And really, we're not going to go into too much depth in this other than just make you aware of there's different types of cabling going to Ethernet switch, and there's other smaller bits of cabling to do what's called a patch panel. And this is an example of what a patch panel is. So if you're an IT manager and all these red and white cables are cables that are run throughout your entire building. Well, they have to go somewhere, so they all literally are in the ceilings or underneath the ground or in the walls. They're all what they call the patch panel or the patch closet, the server room. They all come into the server room where they are all plugged in to one of these ports. And then in order to get those, these are some different tools that you use in networking. There's a wire stripper, because when you're making these cables, there's wires, and you have multiple wires that make up an Ethernet cable. You can have a wire stripper that cuts these, and most IT departments, they just buy the wires, the Ethernet, and they plug them in. But when there's a whole nother group of people, when there's building a new building, when they're running the wires to the HVAC, to the electricity, they're also running Ethernet, RJ45 cables through the walls, and then they'll have to manually strip and things like that to put in the patch panel. So what I was trying to say is, you as an IT professional, this is a good skill to use, but you're not necessarily, unless you go work for a structured cabling company, you're not going to be making Ethernet cables all the time. Once you get these cables run, there's a punch down tool that looks like this, that literally it punches down those wires to the patch cable. And we'll actually do a exercise for that. It's kind of interesting and fun and cool how it works. After you've got the cables exposed from the Ethernet, then you'll use a crimper, which is like a plier, and then you have these little devices, these little slots, where you'll take the end of the Ethernet, push it over the wires, and the crimper will literally crimp this on and put all the wires in securely. So it's all part of this cable making process. And once again, once you're running these wires, these Ethernet cables as an IT pro, you may be on that part, or you may be just on the part of diagnosing. So if there's a workstation for a user that says they can't get on the internet, one of the things you want to test is to see if the Ethernet, the networking cable, the RJ45 from the desk to the server, hasn't been cut. So there's something called the cable tester that is basically a tone. It's kind of cool. You put a tone on one side with a little box, and it creates a tone like beep, 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 beep. And it's really a lot higher than that. But it's putting this tone or signal out, and then you go to the wiring rack when you saw those with all the cables, patch panel, and then you have another little device that it's kind of like it detects this sound, because the sound is just coming over the wire. It's not like a speaker. You can't audibly hear it. But this cable tester device will be able to detect which one of those cables has that tone or pulse, and then you can identify, is this a solid cable, or if not, if none of them, then you have a chopped cable or spliced, or somebody ripped it out of the wall or something, and it has to be fixed that way. And this is kind of what they look like. We talked about the cable tester. So in this case, you've got one end plugging into this little white box, and then the other end is where it's going to transmit those tones. We talked about last time some of the tools of the trade is your multimeter, and you'll also be able to use a multimeter to detect the electrical impulses on the networking cable, so you can test also if you've got a good network pulse there. So another good example of the use of a multimeter. We had talked about tone generator just recently, just now, about the beep, beep, beep. And this just basically tells you until you find, it's kind of cool. You just scan it over, and then eventually you'll say, oh, it's this one, because the little device you're holding starts beeping itself. It's pretty cool. There's something else called a loopback installation and testing tool. So this you basically put on your computer, and this will test to see if your Ethernet port or cable is good as well. So this is just another tool. It's called the loopback adapter that plugs right in and helps you troubleshoot. Other types of cabling that you're going to be running into are fiber optic. Now, typically, this is only the bigger companies. Fiber optic cabling and connectors, instead of copper, which is everything we've been talking about, copper wire. This, and they talk about here, because one of the disadvantages of copper, because it has interference, there's only so far you can run copper. Or as opposed to light, if you think about it, it goes much further, and there's less potential of eavesdropping, interference, and light things that are going over fluorescent lighting that can benefit by going fiber optic cable. So this is stuff right here. We're not going to go into depth right now. You're going to learn more about it in test out, but you will have to know this stuff for your A+. Once again, you're not going to have to know the theory of how the fiber optic works, more that these are the type of fiber modes there are. There's a single mode fiber, there's a multi-mode fiber. As you can see, the single mode fiber is faster, and it goes a long low distance because it's suitable for WANs, wide area networks. And the multi-mode fiber, it's less expensive and it's shorter. Maybe in your office, that's a LAN. So those are two things. You're also going to learn what those different connectors look like as well, which is the next type, because there's different connectors on fiber. There's ST, SC, and LC, and you'll learn all the differences. So one of the things I give advice to all the students, that is something you kind of memorize, because not everywhere will have fiber to work on yourself. So you're going to have to kind of memorize these different terms and kind of what they are and what they look like. But we'll do that really more in terms of your review. Coax cabling, same thing. You've got coax. It's different because it has a insulated wire. You can see here's the wire itself, the little copper wire, and they've got all these different wraps around it. You've got the signal conductor, the insulated second wire mesh conductor, and an EMI shield. These are all things to protect that transmission so it doesn't get the interference from the outside. This is coax cabling, similar to the stuff way back when we used to have cable TV. So this is another type of networking and a different kind of connector. Something is called what they call RG, or radio grade. RG6 is thicker, better quality, and it's used in modern networking, as opposed to RG59, which is a thinner, and this is the older stuff that you probably got used to in the 80s and 90s when you had actual literally cable service at home with the TV. You probably had RG59. It's also called coax. So these are all interchangeable terms. And then, if you remember, kind of like I am, way back when, in the 80s, these are the type of ends. It's called B and C in the end connectors. So you'd put it in and you would twist, and that's what would twist it on. Sometimes they're called F connectors, and you can see a picture of what they look like. So this will be an identify thing you need to know for the A+, of how, what's a coax, what's a F connector, what do they look like? F connector meaning if you ever look on the little bridge here, it kind of looks like an F. That's why I look at it as an F connector, because you go in there and turn it kind of looks like an F. More information here about 10-base-5, coax, hybrid coax. There's a bunch of different kinds of coax. Another networking piece of hardware, we've already covered this, NIC, network interface card. This is the part that data signals, data in and out of your PC. Each node can address others, so we've kind of covered that, but this is very important. It's either an add-in card or it's built onto your motherboard. We're not going to talk about this so much now, other than mention it exists. The different frames of a data packet, we're going to learn about that more in the next class. But next week, rather, week 6. But each of these are data connectors, is a frame. Ethernet NIC features. Once again, this is just good information. We've already talked about some of this stuff. We've talked about PCIe expansion boards. They can be RJ45. They can be fiber optic. They can be multi-port types. They can be copper. And if you remember, there's the physical address, the MAC address. There's the connection port, and there's status lights that tell you if it's communicating. And the cool thing is, if it's communicating at its fastest speed, it's green. If it's not as fast, or like 10 base 100, you'll get like a yellow light. We talked previously about MAC addresses. That's the physical address on the card and the adapter port. Here's an example of what it looks like. Each network card has one, and that's a good way to narrow down which packet or which Ethernet card is transmitting or receiving. Typically, a good example is of a virus. If there's a virus on a workstation and it's transmitting tons of data, as the IT manager, you can look up the MAC address, and then you can more easily find which PC has the virus on it. We talked about LEDs. We talked about switches. Microsegmentation. So bigger switches have up to 48 ports, like the one I've got here in my house. It's a 48 port Netgear. But the only point of this is that you can segment the switches into groups. So you can do every 12, you can do 4 groups of 12 as their own individual segments. They can go half speed, half duplex, full duplex, and they're much more powerful ways to manage your data. Because as you remember, we talked about managed and unmanaged switches. Unmanaged switches are more small offices. They just are doing basic work, as opposed to the bigger managed switches for the bigger companies. They have to be configured by the administrator. Remember, we just talked about that console. They can, have thousands of ports, and you can have virtual VLANs, are what they call when you can segment the switch. Here's an example of some Cisco larger series switches, 9400. And the cool thing is, there's whole other classes beyond A+, which is more of an overview, in-depth programming and customization of Cisco and managed switches. And you can see there are lots. That's a whole other course and certification on its own. They've got their own language, their own programming. The good news for you, the A+ student, you're not going to have to know any of this stuff in this detail, just to know the difference, and there is a managed and unmanaged switch. We've got power over Ethernet. This is really cool. I love power over Ethernet. It's called PoE. Basically, most switches, they have their own power, but what this one does, power over Ethernet, on one or more of the wires on the Ethernet jack, it transmits power. So for example, a good application is on IP cameras. You can take an IP camera and plug it in somewhere. Just so long as you plug that Ethernet switch, it's going to power the camera, so you don't have to run a whole nother power line to the camera. So if the camera is way up in the ceiling, that's something that we've used for years. We talk about my company, iRecord, where we install IP cameras all over the world for police and law enforcement. Before we had IP cameras, the technicians would have to have one camera, a power line. You'd have to run a separate power line all the way across the interview room, a separate video line. Now, the beautiful thing is you plug in that RJ45, just so long as the switch. Now, when we say switch, power over Ethernet, the switch has to be PoE, power over Ethernet. So when you're looking on eBay or whatever for switches, and if you need a power over Ethernet, make sure it says PoE somewhere in the switch. And it talks to you about some certifications and things. This was really cool. Ethernet over power. You've got adapters that look like this. I've actually got some here at my house. The cool thing is, for some buildings, offices, locations, you might have far locations that it just running Ethernet, you can't do it. There's cement or steel or something. So the cool thing is you can literally plug this little box into a power switch, and then you plug in your Ethernet to it, and now it'll communicate via your power lines, and it'll send the data over power lines. So it's really cool. And literally, it's no different than this. You plug the thing into your power, so your power grid in your house is now what sends the IP traffic. So you've got to have one of these devices, like here at my one desk, and then there's another one of these near the server room. So you just don't plug it in. It has to have two ends to it. Typically, the other end is in the server room, so that's when it connects into your switch. So really cool technology.